Right. Just to refresh your memory, so far we talked about SPI and how does it work, what are the different pins that we have in SPI, and the frequency, the mode. So two things that we need to consider when we work with SPI. So if you buy a device, you need to check the data sheets. The first thing is the frequency, the maximum frequency that you can use, which you can find in the data sheet, and the mode. So is it mode 0, 1, 2, or 3? And of course, the mode depends on the clock, polarity, and phase. So is it rising edge or falling edge, in phase or out of phase? And those are the things that you need to, if you want to use a microcontroller as the master, so you need to include them to configure the port first. So before using the port, you need to configure it to match the same configuration of the slave. All right, so we said we have two ports in the embed. One is in pin 5, 6, and 7. So those are the master output slave inputs pin, the master input slave output pin, and the clock. We have another one in pin 11, 12, and 13. So 14 is not part of this, yeah. So we have this green box is the SPI, and of course we should have the shift register and we should have the clock source in the microcontroller. If we want to configure those pins as SPI port, we need to create an SPI master. So we have other functions for SPI slave. So I can use the microcontroller as a slave, or I can connect it to another microcontroller, and I will show you this later on. If we need the microcontroller to act as a slave, we need a different set of functions. Right, so for master, we have the function that we can call once we configure the pins is the format. So the format is you configure the data transmission mode and the data length, how many bits you are going to work with. Is it 4-bit, 8-bit, 16-bit, and so on, right? So this function accepts two parameters, which is, I think you start with the data, for example, 8, and then you put mode 0, and that's it. So you work with 8-bit and the mode is 0. And of course, this information should match the one for the slave. And then frequency as well. You set the frequency, you provide the frequency. And the value that you provide here, so it's in hertz. And then the most important function is the write. I think we talked about this. Write, it does everything basically. So it initiates, as you know, we have master, slave. So data goes to the shift register, from the shift register of the master to the shift register of the slave, and from the shift register of the slave to the shift register of the master. So once we call the function write, usually we call it this way, x is equal write, and then you provide an information. Of course, you need to include the name of the port here before write, and the data to be transmitted, y. So basically we will have y here. Here, we don't know this what we want to get. Once you call the function write, clock will start, clock signal, shifting will happen, and those x's will be transmitted to here, and y will be transmitted to the other shift register. And then those x's at the end, once the transmission is done, it will be assigned to x. So the value, the new value that's received is received by the master, will be assigned to x. So only one function call, it does everything. And this will make our life very easy when we work with the SPI. Is this clear? And as you can see, there are many things done by this function. Right. If we don't call the forma and frequency functions, those are the default settings. So it's 1 megahertz, 8-bit, and the mode is 0. So for example, if you have a slave that works with 8 bits, that its mode is 0, and it can have a running frequency maximum, let's say 2. So you can work with this with the default value, because I can use any frequency less than 2. I can go up to 2. So you don't need to call the function format and frequency. Is this clear? If you don't have those values, then you have to call them. You have to configure it to the right one. Right, this is a simple example for a master. So what I did, I have the microcontroller. I just wrote this code, and I'm going to send value. I didn't connect anything to the microcontroller, so I have those pins, master out, master in, and the clock. So those 3 pins, I'm just going to use them. I didn't connect them. I just wrote this code and I ran the code. And then what I did, I took the oscilloscope and I observed the signal on the clock and the signal on the output. So what is going to be sent to the master, to the slave from the master? Right, so the first thing is to configure the port, SPI. So I'm using pin 11, 12, and 13. So I'm using the second port. I called it SER underscore port or serial port. I have 2 characters. I'm going to send 8 bits. And of course, when you send 8-bit, you can get 8-bit, receive 8-bit. So I call the first one switch underscore word, and the second one is receive value. So basically what I want to do, we have the shift registers. So what I want to put here, I want to put here the switch word. And basically what we will have here is the received value. Once we call the function, this received value will come here, and this one will go there. And then we assign it to the variable received value. This is what I want to do basically, and that's it. So I start with, and again, do you see I'm putting this outside while? Because I don't have to keep configuring every time. So let's say that I have a while one, so the statement will be executed continuously. I just configure the port once. I don't have to configure it each time I need to use it. So you configure it once and then that's it. Unless you want to change the configuration later on. So if you have, for example, 3 or 4 slaves, and each slave has different mode, in this case, you need to change the mode before you use the slave, the one that you want to use. But if you are working with one, it's just one configuration and that's it. So I'm working with 8-bit. The mode is 1, which means C pole is 0 and C phase is 1, which means rising edge in phase. And then inside my while one, so I assign A1 a value. This is a dummy value that I want to send. I assigned it to switch word. And then I call the function received write, function write. Received value is equal, and then I call the function write, and I passed this number to it. So this is the number that will be in the shift register, and it will be sent to the outside, to the slave. So basically here you can put directly the value. You don't have to assign it to a variable and then you put the variable here. But if this value is going to change, then it's better to work with a variable. For this example, you can even put it here. Is this clear? And that's it. So this is basically what's simple code for a master. and this, if you keep calling this function, which means each time you are getting a new value from the slave and sending the same value to the slave. Right, if we do this, which bit will be sent first? If I have the A1, what is A1? A1 is 1, 0, 0, 0, and then I think it's 0, 1, 0, 1, right? Which bit is going to be sent first to the slave?
Most significant bit.
The most significant bit. Good, excellent. So if you have this in so this is how it goes. So this one goes first, and then 0, and then 1, and then 0. So if you observe this output with the oscilloscope, you will see that you will get it in this order. So this one first, 1, and then most significant bit, and then 0, and then 1, and then 0, 0, 0, 0, 1. This is how they will be transmitted, and this is what I did. So I observed on the oscilloscope. So this is the clock. So this is time. And this is the voltage. So this one is 3.3 volt. And this is what I got. So remember we said is rising edge. So we are working with rising edges and in phase. So do you see this is 1, 0, 1, 0, 0, 0, 0, 1. So those are the bits that have been transmitted. And of course, this one is the first, right? Because we start from 0. This is time. We start from 0. So this is the first bit that was transmitted. This is the second bit, and so on. This was the last bit transmitted. And as you can see, for each rising edge, we have 1, and then we have 0. Next rising edge, the next rising edge is 1. And this is basically the my number 1, 0, 0, 0. 0, 1, 0, 1. So this is A, and this is 1. Just this code. It does everything. Basically, this is the important part, this line. Is this clear? Right.
I have a question.
Yes.
Regarding this, the wait statement corresponds to 1 over the frequency.
Pardon?
The wait time we use, it corresponds to the